Okay, thank you very much. I'm very happy to be in Barcelona and to work with Jack. I will present the project we are working on since 4 years now. It's a competition we won in Taiwan in 2011, and it will be finished in 2017. And what I will show now is all the project, and maybe it's linked to the, I don't know where to look. Okay. So this is like maybe what is linked to the topic of the symposium is it's a 70-hectare park, so it's a new district for the city of Taichung in the middle of Taiwan, and it's an old airport, and there is a 290-hectare site, and the park is a little like Central Park in New York. It's a central place in this new district, and all this around the park will be new building, new construction, university, office building, and housing building, and so it was completely empty, so there is no demolition. The site is was completely, it's an airport with no construction. And so we need to build from nothing a new place. And so the strategy for doing that was maybe to imagine what could be a strategy for urban design today. And we could do an history of urban design, but maybe one important thing that could come again is the question of climate, because maybe the city was based on some other idea during the 18th century, 19th century, 20th century. For example, it was based on car and transportation, and maybe the question of climate, of pollution, of this type, of the quality of the air, quality of the city could become the main topic, and so it's why we base all the project on the climatic issue for the project, and and also because in Taiwan it's a warm and humid and polluted like all the city in the world today. And so we were challenging these three topics because when it's warm and humid, it's not very comfortable, and so people prefer to stay in air conditioning shopping mall and not to go outside. So the challenge was a little like the Parisian park in the 19th century, to bring freshness with the trees, with a green area inside the city, or with a clean to clean the air like the Central Park. In New York. And so we have based the project on three layers, one about heat, one about humidity of the air, and one about pollution. And I will show that. Maybe it's important to understand that we are not coming back to a kind of modernist vision of the best climate and the worst climate. And we have to do only a good climate. We are thinking that we could work with intensity, with gradation of quality, and to offer some polluted area, because there is some polluted area, to less polluted area, or to let high hot space, but to create also some cool space, so to give variation, a different intensity of quality of space. So. And also the strategy of composition is based on that, because we work independently on the three layers, on heat, humidity, and pollution. And by overlapping these three layers, it creates some random microclimate, like hot, humid, and polluted, or hot, dry, and non-polluted. So it creates a variety, and for us it's important that there is this diversity of space, and not to be only homogeneous. So the first layer is based on the heat, And the only parameter was the wind, because there is a north wind that cooled the space, and so we have analyzed where comes the wind. And then we have, with Transolar engineer in Germany, we did the CFD map that show all when there is this main wind inside the city that comes from the north, where it will be more speed or less speed. And so the high area with a lot of air, with speed air, are the red one, and when it's blue, it's not so much windy. And from that, we could understand that it will be more comfortable when it's very hot during the summer. It will be more comfortable to stay in a windy area. And so from that, we have created this, from this software model, we have created the master plan. So the master plan comes from the climate. It's not a graphic design or some other issue for making the master plan. It's just coming from the climate design. And from that, so from the climate, we have a composition, and the composition is based where it's a little more windy, so we increase the coolness by placing a lot of trees, by placing what we call climatic devices to increase the coolness of the space. And where it's cold, if it's warm, so we let that, and all the composition is made by gradation. So this is like the trees map. So there is a lot of 15,000 new trees that will come in the park, and this is what we have called climatic devices. And we say that first we design the climate, and then we have the form, and then we have the function. So we propose to have in the cool area all the leisure activity, and with a kind of possibility to change in the future, so we don't fix the program inside. And then we do a second map for the humidity. This is all because this new park receives all the rain from all the new districts that will arrive on the park, and there is a delay for maintaining the rain before it goes in the duct for going to the sea. So there is some lakes that could be created when there is a lot of rain. And so from that, we understand that this is more humid and less dry, and we increase the dryness by placing trees and climatic devices that avoid the humidity of the air. And the last map is a composition of pollution. So we have big roads that cross the park, and far from the road, we map the clean area, less noisy, with less car pollution, and we increase this quality by placing a lot of trees that will absorb the pollution, and some climatic devices that clean the air. And we also propose to have at the end all the children activity, the playground that could find location in this area. So this is this type of these three layers of heat and humidity and pollution. And then by overlapping, it creates this random situation. And then we give name to this because we have some main areas, so we give a name. So it's like we call that the Kulia, the Drya, and the Clearia. So, and we give the northern Kulia. So it's like the identity comes from the composition. And then also the way of creating the road inside the space is like to connect all, for example, we have the clean, the cool pass, and the cool pass connect all the cool areas, so you could walk inside the park without heat, without sun, so this is like one, that is like an isobar line, so it connects all the more cool area inside the park. And then we have the dry pass, and the dry pass is connect all the dry area, and we connect that to sport activity because it's better to do sport when the air is more dry because you have more perspiration. So this pass is designed in another way. the clean path is more soft with soft heel, and this one is more difficult to take. It's more for sport people because you have to climb some hill and go down. So this is like another type of moving through the park. And also the bench have a firm design, so it's just to stay, you still stand. And the last one is a clean path, so it connects all the. It's a less noisy path. It's a larger path with very flat, and it's for the baby car and wheelchair, and so it's more for family. And it connects all the clean areas, and there is also another type of bench, more like a sofa with a lower for children, lower. And so it means that we create these three types that have different quality, and of course everything overlaps, or everything there is some meeting and crossing of all these things. This is, for example, here we are on the dry path, and this is like the cool path that could and then I want to show this is like we call that the coolia, the cool strategy of design. So it's to find place for cool area, and this is the 4 coolia we have in the space, and this is the strategy for placing the trees. So where it's very the most natural colder area, we increase that by placing a lot of trees, and then we have a gradation. So it's like you are cover, there is some shadow, you have evaporation of the trees, so it's like a very, we increase to cool this area, and then it's become more hot, more warm, and the density of trees change. And sometimes we introduce these black dots, that is a kind of climatic devices, so it's another type of experience of creating coolness by at the size of the trees, but with some other techniques. The choice of the trees also is linked to that. So we choose trees that have specific quality to cool more. So it's trees with a lot of leaves, or big leaves, or white leaves to reflect the sun. So there is a choice, not a decorative choice, but a choice for choosing trees with some cooling quality, and this is the type of, and then there is this climatic devices. So it's like a tree-size man-made object that use some other strategy for cooling, like by convection, by evaporation, by radiation, by some different way of cooling. And because we could cool by blowing on the skin, by lowering the air temperature, by stopping the heat coming from the radiation of the sun. And this is like one. All the energy that is used in the park are only green energy, so we use geothermal cooling by going 5 meters underground with a duct for cooling the air. That is always 25 degrees Celsius in Taichung. So it's when it's 35, it goes down, and it's cool, and it goes out. And for moving the air, we have 7,000 square meters of photovoltaic panels that create a kind of landscape of like a canopy on the garden here, and we are in a new phase to create 3,000 square meters here. So it's only green energy. There is no energy that creates a green gas effect. And this is one device we made. We call this one Anticyclone. So this is a model we made with the engineer in order to calculate the quantity of air, the speed of air that should be blown to have an effect on the outdoor space. And this, then we have the machine that blow the air underground and the duct that go inside the park, like there. And so all this, what we call the climatic plant, contain all the material. Okay, we'll go quickly. And this is one climatic plant with some device. This is the air going underground, and this is the anticyclone. Okay, and there is some other, like by evaporation, by blowing water that evaporate and cool the temperature around, and there is also some solar that are filtering the sunlight with more heat. And some other, and then there is some strategy for the drying devices and driving plant, and for pollution with some to blow some clean air. And then, of course, there is some building, but I will go directly on the intelligent system of the park. Just there is a problem. On the, I don't know.
Is there a video, maybe? Is there a video?
No, there is something after that. Ah, okay. Yes. So in the park we will have every 50 meters we have one sensor that measures in real time the temperature of the air. So this is a network of sensors. So we measure the temperature of the air with all the sunlight, the speed of air, the humidity of the air, and also the pollution, the different gas pollution, particle matter pollution, noise, and all this creates 3 maps that we could have on the smartphone. So in real time we could see where it's more warm or less warm, or more polluted or less polluted, so you could decide to go to move inside the park, to go in the most colder area, or in the most cleaner area, or in the most polluted area if you want. And so we create an index of 6 colors, so this is the most warm and the most cold. And then the way for using the electricity, we have this 7,000 square meter here, and so from this, because all the electricity of the park is produced by the solar panel, by the photovoltaic panel. So it means it's first go to we keep the electricity for the night, for the lighting for the night. We use it in real time for the building, and then if we still have some electricity, we could use it for blowing, for activating the fan of the device. So it means if it is very warm, if it is during the summer when there is a lot of sun, so it means it will produce in real time a lot of electricity, and so we could have a lot of devices on because we have more electricity. And when the sun goes down during the evening, so the device stops, but it's in the same time that the air is becoming more colder. So this is like the production of electricity. So this is the sunlight. So we have a lot. So a lot of devices are on, and then it's and this is the smart application that could give you some information in real time, so you could decide to move inside the park, linked to the humidity of the air or the pollution, and you could have in real time some information about all the different parameters. And this is finished, and I just show some image of the park under construction. Okay, thank you.